Hi, good morning. So I want us to actually get something very clear. Whatever time of the day that you're getting this video, so I just want to pass across the time of the day. Good morning, good evening, good afternoon. So I want us to get something very clear now. Resolution of retinoscopic findings on optical cross. So I want us to get the difference because some people do get confused, and people or clinicians, optometrists use different methods. Some use meridian method, some use axis method. To my left here is axis method. To my right here is meridian method. So side by side, I want to juxtapose the two of them to make you understand that they are all the same. Whichever method that you want to use, that you feel is most suitable for you, you can go ahead. They all end up giving the same result. But however, at the end of this video, I'll also make us to see why I would prefer meridian method to axis method, why meridian method carries more legitimacy than axis method. You will see that later, and I will try not to forget after all of this. Okay, so let's start with the axis method. Now, what is axis method and how is it done? It's very simple. It's just done in the reverse of the meridian method. So now, what it means is that when you are scoping the horizontal meridian, your retinoscope streak is definitely vertical, and your movement is along the horizontal axis. You are scoping the horizontal meridian, your streak is vertical, you are scoping the horizontal meridian. So now, whatever power neutralizes your horizontal meridian, what it means is that you place the power on the vertical axis. On the vertical axis. Place power on the direction of your retinoscope streak. That is what axis method is. Whatever is the orientation of your retinoscope streak during scoping, that is where you are going to place the power at the end when at neutralization, the power you get at neutralization. For instance, if my streak is vertical and I'm scoping the horizontal axis, the power that neutralized it for me, the power that neutralized the horizontal meridian for me is +3. Now let me repeat myself. My streak is vertical, I'm scoping the horizontal meridian, and the power that neutralized the horizontal meridian for me happens to be +3. Now I'm going to write that +3 on my vertical axis, since it's an axis method. Write it on the vertical axis because that's the origin of your streak. So this is it. I'll write +3. This is it. Even though it was the horizontal meridian that I neutralized, I'm going to write the power at the orientation of my streak. Scoping the horizontal meridian, my streak is vertical, 90-degree orientation. So that is why it's called axis method. Place the power at the orientation of your streak. Now, my streak is now readjusted to 180-degree, and I'm now scoping the vertical meridian. Whatever power that neutralized that vertical meridian for me, I place the power at 180 because my streak is oriented at 180. So let's assume +2 neutralized my vertical meridian. So I write +2 here. Okay, so let's juxtapose it to meridian method. In meridian method, when my streak is vertical, I'm scoping the horizontal meridian. And +3 is what neutralized it for me. +3 neutralized the horizontal meridian. My streak is vertical. I will have to write the power on the meridian as against the axis method. In meridian method, you write the power directly on the meridian that you are scoping. So now I've neutralized my horizontal meridian. Now I want to neutralize my vertical meridian. The streak of my retinoscope is now horizontal. Movement is along the 90-degree. Now +2 happens to be the power that neutralized my vertical meridian. Now I'm going to place that +2 on the orientation of my meridian, which is vertical meridian, which is meridian 90 +2. So you see, these two methods are directly opposite. These two methods are directly opposite. These two methods are directly opposite. End of the day, they will both give us the same result. Now, let me go through the resolution. Now, let's come back to axis method. How is it resolved? Now, you see, +3, axis. This is axis method, axis 90. Now +2, axis 180. Of course, this is axis 90 and this is axis 180. That means +3 is on axis 90 and +2 is on axis 180. This notation is not actually right to whoever knows the rule of optical cross. Whoever has studied the behavior of lenses knows that this notation here is very wrong. Why? Because you cannot place a power on the axis. Where the axis is where the power ends. Powers should always act 90-degree away from their axis. This is saying something else. We are going to come back to this. I said we'll discuss it at the tail end of this video, right? So to resolve this, now definitely my sphere is the highest plus, which is +3. So I write it. I take it out. I take it up. But then I have to subtract my walking distance. Let's assume my walking distance was +150. So +3 minus 150, which is +150. +150 minus the difference between the two axes is -1. You subtract the big one from the small one. That is +2 minus 3 is -1. That gives us our cylinder. What axis are you going to use? You use the axis of the one not taken. You use the axis of the one not taken. I took +3 as my sphere. +2 was what I didn't take. So therefore, I take the axis of the one not taken. The one not taken here is +2. And the axis of +2 here, as indicated, is 180. Therefore, 180 is the axis. So this is what we have resolved. This is what we have resolved. Now, let's shift to the meridian method and resolve it to see what it gives us. Now, +2. Let's resolve it. +2, axis 180. Yes, because +2 is acting on axis 180, which is more correct. And +3 is acting on axis 90, which is very much correct. So just like we resolved the other time, you take your highest sphere, your highest plus as your sphere. Our highest plus here is +3. But then we also have to subtract our walking distance, which is 150. So +3 minus 150 is +150. Then the same thing, we subtract the two sphere powers. Since we are using two sphere method, we'll subtract the big one from the small one to get our cylinder. We need our answer to be in minus cell. Mostly optometrists, like I've always stressed out, work in minus cell. So our cylinder is -1. Now over to the axis that we are supposed to take. Once again, you take the axis of the one not taken. I took plus 3. I took plus 3. Plus 2 is what I did not take. The axis of the one not taken. The one not taken here is plus 2. And the axis is 180. So therefore, 180. So we ended up with the same answer. 1. We ended up with the same answer. So whatever method you actually follow, you end up having the same answer, be it axis method or meridian method. So what I want to do next is to try to prove to us, or to make us see why axis method is less correct, less conventional to someone that has the knowledge of optics and the behavior of lenses as compared to meridian method. Now follow me closely, please. Now, this is plus 3 and this is plus 2. This is the axis method. Now, conventionally, the standard is this plus 3 should be acting on 180. The axis of plus 3 should be 180 and the axis of plus 2 should be 90, because the rule says that where the power is, where the axis is where the power ends. That is to say, the power always acts 90 degrees from where from the power acts 90 degrees from the axis. So that is to say, plus 3 should have an axis of 180 and plus 2 should have an axis of 90. That is where it ought to be. You cannot place a power on the axis. No, that's not how it's supposed to be. You should have the axis 90 degrees away. Because what this means is that this is axis method. This plus 3 is on axis 90 and plus 3 is not supposed to be here. It's supposed to be on the meridian. You place powers on meridian, you don't place them on axis. Because powers, for them to act on a particular axis, they have to be 80 degrees apart. You place powers on meridians, you don't place them on axis. The rule says that where the axis is where the power ends. That is to say, if you place a power on the 90 degree meridian, it is actually acting 90 degrees away. That's the axis. It is acting on the axis. So here, using the axis method, it means that plus 3 is acting on 90 degree axis, which is very wrong. Right? So this, another way of putting it is see plus 3 axis 90 plus 2 axis 180. But this is very wrong, right? So now this is meridian method, plus 2 at 90 plus 3 at 180. At, that is meridian 90. At plus 3 at 180. So that means if you want to note this in axis form, plus 2 axis 180 and plus 3 axis 90. The axis should always be 90 degrees away from the meridian. At 90, that is at, whenever you see at, it means that you are denoting the meridian, plus 2 meridian 90. This is correct. Come over to this. If I say plus 3 at 90. So now, let me now denote it in the axis form. The axis ought to be plus 3, 180. But look at what we have. This is supposed to be the correct form. But look at what gave us that resolution here. Plus 3 axis 90, which is wrong. That is what I've been trying to make us understand, that axis method is not as correct as meridian method. So that brings us to the end of this video. The next video should be how to resolve for symmetry when you want to decide or determine the power of lenses using a manual lensometer.